Why is it that you can't remember the first few years of your life? Think about it. You learned to walk at 1, you spoke your first words at 2, and by 3, you were playing games, laughing, and exploring. But when you try to reach back to those moments now, all you find is a foggy void. Yet, during those years, your brain was learning non-stop, recognizing objects, distinguishing voices, and trying to crack the rhythm of language. The answer is both simple and a bit complex. Scientists call this infantile amnesia. The definition is straightforward. On average, humans cannot remember the first 3 years of their lives. This is a universal phenomenon. It doesn't matter your race, culture, or gender. Everyone forgets. But why? One of the first people to pursue this question was Sigmund Freud. According to Freud, this forgetting was all about repression. He believed we forgot because we were suppressing childhood traumas. However, this theory has long been abandoned. Why? Because an infant's memory doesn't just forget trauma, it forgets everything. Today, researchers are explaining this with much more solid scientific foundations. One of them is Sarah Power, a researcher at the Max Planck Institute for Human Development, and an experimental psychologist studying mice, children, and memory. According to her, we must distinguish between infantile amnesia and childhood amnesia. Infantile amnesia is the total inability to recall memories formed between ages 0 and 2.5. Childhood amnesia, on the other hand, refers to the blurry, fragmented, and incomplete memories from ages 3 to 6. In other words, the brain does record for a while, but those records eventually become inaccessible. So, what exactly causes this? During her research, Sarah Power conducted fascinating experiments with baby mice. These mice were exposed to specific experiences at a young age. As they grew up, they were tested to see if they remembered them. The answer was clear: they didn't. However, biochemical traces of those experiences were still present in their brains. This meant the mice had learned, but they couldn't consciously access the memory. The answer to whether these records were just silent or completely erased came from genetic engineering. Researchers modified specific proteins in the hippocampus of some mice, specifically the NMDA receptors. The result was striking. The mice began to remember the memories they had supposedly forgotten. This implies that early childhood memories aren't actually deleted. They just become inaccessible, as if they are buried deep within the brain's biological vault. It's a kind of biological locking system. And this isn't just for mice. Traces of this same system are found in human infants as well. A 2020 fMRI study showed that when babies under the age of 2 encountered a visual object for a second time, there was activity in the hippocampal region of the brain. The brain recognized the object, but because the capacity for linguistic expression hadn't developed yet, the memory couldn't be spoken. This brings us to a crucial question. Is information enough for a memory, or is the ability to tell a story the cornerstone of remembering? For most of us, our first clear memory dates back to around age 3, a birthday cake, a fall, or a lost toy. That specific moment where we first identified with a sense of self. But why exactly at that age? Because remembering requires more than just an event. It requires a framework to understand that the event belongs to us. We are talking about the self. In psychology, this is called autobiographical memory, the ability to encode lived experiences as part of our own story. This ability isn't innate, it develops, and its growth depends on 3 major factors. First, language. Language allows us to put events in order, establish cause and effect relationships, and make details meaningful. When language hasn't developed, memories remain silent. The child's brain might record, but without language, those records are filed randomly in a cluttered archive. To remember, you need a librarian at the head of those files, and that librarian is language. Language gives a name to events. Once something is named, it becomes definable. And once it is definable, it becomes memorable. Second, Self-awareness. Children realize that the reflection in the mirror belongs to them around the age of 18 to 24 months. This is called the mirror test. If you put a bit of invisible paint on a child's forehead and they touch the spot while looking in the mirror, it means they are now self-aware. This awareness is a revolutionary moment for memory. The child is no longer just a passive observer of events. They become an actor. A thing doesn't just happen anymore. It happens to me. This is how memory is built. A world belonging to me, events belonging to me, and the meaning I attach to them. Third, the perception of time. Grasping when an event took place is fundamental to memory. For a 2-year-old, everything is now. But starting from age 3, the distinction between past and present begins to form. This allows memories to be placed on a timeline. The event wasn't just experienced, it was experienced in the past. When these 3 elements, language, self, and time perception, come together, the brain begins to produce episodic memory for the first time. This is the memory of where, when, and how things happened. But this raises another question. If episodic memory only kicks in around age 3, why don't we forget how to walk, run, or ride a bike? The answer is that the brain has more than one memory system. Episodic memory. This is your remembered life. It's your classic memory of a birthday, a wedding, or an accident. It's formed by the joint work of regions like the hippocampus and the prefrontal cortex. Infantile amnesia stems specifically from the late development of this system. Procedural memory. This is what our bodies remember. Skills like walking, swimming, or riding a bike. Controlled by the cerebellum and basal ganglia, it doesn't require conscious recall. You can't explain how you do it, you just do it. This system develops much earlier, which is why we talk without remembering the moment we learn to speak. Semantic memory. This is our warehouse of facts. Paris is the capital of France, or an apple can be red. These are facts, not episodes. We don't remember where we learned them, but we know they are true. Interestingly, many childhood events are erased as episodic memories, but are converted into semantic knowledge. The memory vanishes, but the information remains. Emotional memory. These are feelings. Without time or place, certain smells might remind you of your childhood. You don't remember where or with whom you were. You just feel it. Controlled by the amygdala, this is unconscious. Traumas, fears, or joys often settle independently of the actual event. Working memory. Think of this as your mental desktop. It's what you use to keep a phone number in your head for a few seconds. It is managed by the prefrontal cortex and develops until age 5. But why is childhood memory so fragile? Even after age 3, things don't go perfectly. Some memories stay while others fade. The biggest influence here comes from something you might not expect: the stories our parents tell us. Remembering isn't enough. You have to keep the memory alive. Memory is an active system of storytelling. Experiments by psychologist Patricia Bauer showed that when parents talk with their 3-year-olds about the past, asking open-ended questions like, "What happened next?" or "How did you feel?" those children remembered more details as they got older. But there was a catch. It only worked for the children who were telling the story, not just listening. This is known as active reconstruction. Every memory is reshaped the moment it is remembered. Every time you tell a story, you update and strengthen that memory. This means parenting isn't just about physical needs. It's also memory architecture. Memories that aren't told are eventually erased. Stories that aren't spoken disappear. The reason we don't remember so much of our early life isn't just the passing of time. It's that we may have never talked about those moments. Ultimately, forgetting is not a failure of memory. Perhaps it is the design itself. Sarah Power suggests that infantile amnesia might be a deliberate reset mechanism. The brain collects all possible signals, then prunes the unnecessary ones to clear space for the construction of a personal identity. It's like the initial setup of a computer. The hardware is ready, but the primary operating system is loaded later. This allows us to become social, cultural, and moral beings. We make room for learning by forgetting. While some animal species must remember every second from birth to survive, the human infant is part of a community. Our development is shaped by the guidance of others. The human brain learns to belong before it learns to be an individual. And perhaps that's why those first memories are erased, because they belong to a time before there was a me to experience them. So, what truly defines us? Is it what we remember or what we have forgotten? Those gaps, the first laugh, the first touch, are the invisible bricks that built who you are today. We are not just the sum of our memories, we are also the sum of our voids. And perhaps we forget our childhood so that we can have the space to write our own lives anew.